Okay, good morning. Today we will start a new lesson, lesson 6, which is talking about trigonometric function or trigonometric ratios. Sorry. In this lesson, we will learn how can we find or how can you use the trigonometric ratios. So here, today we will learn about something new, which we call them trigonometric functions. Now, the first thing that you have to know that the trigonometric functions or the trigonometric ratios are ratios used to solve the right triangle. So the trigonometric ratios are ratios that's used to solve the right triangle. Only for right triangle. You cannot use it if you are talking about an equilateral triangle or for acute triangle or any type of triangle. Only for right triangle. So to solve the right triangle, you can use the trigonometric ratios or Pythagorean theorem. Pythagorean theorem is related to the length of the legs and the hypotenuse. The trigonometric ratios is related to the angles of the triangle. So the Pythagorean theorem, this is a way to find the length. The trigonometric ratios, a way to find the angles. And both of them are working on the right triangle. Now, last semester, when we talked about the right triangle, we said that the longest side is the hypotenuse, and the other two sides, we call them legs. Today now, we will name these legs. We will not say leg and leg. No, here we have to name the legs. When we want to name the legs, they have to be named according to the angle. What does it mean? That's mean here we have the hypotenuse. It will not be changed. Any triangle and any type of right triangle, the longest side is the hypotenuse. But to name the adjacent and the opposite, they have to be related to the angle. This is an angle A. The side that is opposite to the angle A, we call it opposite. Okay? And the side that is beside an angle A, we call it adjacent. Okay? So here this is the angle A. The side that is opposite to the angle A, we called it opposite. And the side that is near or beside an angle A, we called it adjacent. Is it clear?
Yes, teacher.
Okay. Then I told you for the adjacent, for the opposite, when I want to name it, it will be related to the angle. Let's see now here, what did I mean? Here we have three triangles. This side, we call it hypotenuse. Now, if I am talking about an angle which is here, let's name it angle C. Okay? Now, if this is an angle C, here we have the opposite. Because this is the side that is opposite to the angle C. And here is the side that beside it, so we called it adjacent.
Miss?
Yes?
I didn't understand it very well.
Okay, this is a new idea. Wait. Here we have angle C. Okay? The side, this is the side. I'm talking about this side. I want to name it. Huda, before that, we said that this is hypotenuse. And here we have leg. And here we have leg. Today, I will not say leg and leg. I want now to name them. To say this is opposite, this is adjacent. But when I name it, I will not choose the opposite as I want or the adjacent as I want. I want to name it according to the angle. If it's the angle here, so the side that is opposite to the angle, we call it opposite, and the side that is near the angle, we call it adjacent.
Okay, Miss, thank you. I understand it now.
Let's see another example. I know this is the new idea, that's why. Here we have angle A. For this angle A, where is the opposite? It is here.
No, this is the...
Bravo. This is the adjacent because it is the side that is close to the angle. And here, this is the side that is opposite to the angle.
Opposite.
And this is the hypotenuse.
Hypotenuse.
So I will repeat now. This is so all the trigonometric ratios used only for right triangle. The angle C is here, so this will be the opposite, and this will be the adjacent. Now today also, after and before that, did you all of you did you understand here how can we name the adjacent and the opposite?
Yes, Miss.
Yes. Now let's talk about the trigonometric ratios. The ratio of the length of the opposite I have to write where. Wait a minute, please. Now, so let's say here that we have an angle A. For angle A, this is the opposite. And this is the adjacent. And this is the hypotenuse. Now, as I told you, its name is an trigonometric ratios. Now, the ratio of the length of the opposite. The length of the opposite side to the hypotenuse, or the length of the hypotenuse, so the ratio of the length of the opposite to the length of the hypotenuse, sorry, we called it sine the angle A. Sine the angle, that's mean the length of the opposite over the length of the hypotenuse. So sine of angle A, that's mean length of the leg that is opposite to the angle A over the length of the hypotenuse. We write it as sine, S-I-N. This is the mean of sine. The ratio of the length of the side that is opposite to angle A over the length of the hypotenuse. Like, if the length of the opposite here, as an example, 3, and the adjacent 4, and the hypotenuse 5, and I want you now to find sine the angle A. You have to know that sine is opposite over hypotenuse. Where is the opposite of A? It is here, 3. Where is the hypotenuse? It is 5. So you will tell me now that sine A is 3 over 5. Is it clear?
Yes. Yes.
Okay. Yes. So let's now memorize that sine A is the length of opposite over length of hypotenuse. Now, the other ratio, that the length of the adjacent over the length of the hypotenuse, we called it cosine angle A. And you write it as C-O-S-A. This is mean cosine A. So the cosine is the length of the adjacent over the hypotenuse. The sine is the length of the opposite over the hypotenuse. How can we find the cosine? The same as we found the sine. Cosine A, where's the adjacent here? It is 4. And where is the hypotenuse? It is 5. So I will say here, cosine A is 4 over 5. Now, the third trigonometric ratios, which is the length of the opposite over the length of the adjacent, opposite over adjacent, we called it tangent of A. The tangent of angle A is the length of the opposite side to angle A over the length of the adjacent, and we write it as tan A. These are the 3 trigonometric ratios that you have to know it: sine, cosine, and tan. Sine is opposite over hypotenuse. Cosine adjacent over hypotenuse. Tan is opposite over adjacent. And these ratios, either sine, cosine, and tangent, are used to find the measures of sides and angles of right triangle. So the Pythagorean theorem used to find the sides only. The trigonometric ratios used to find the angles and the sides. For right triangles, you cannot use them for this one here. Yani as an example, if you have A, we cannot say this is the hypotenuse and this is adjacent. No, this is false. This cannot be. I will repeat, only for right triangle. So remember, Pythagorean theorem, trigonometric ratios only for right triangle. Is it clear?
Yes. Yes, teacher.
Okay, now let's have more examples. Inshallah, it will be understood. Finding the trigonometric ratios. What are the sine, cosine, and tan A for the triangle shown? First of all, before I wrote the ratios, I have to mention where is the hypotenuse, where is the adjacent, and where is the opposite. Here, I'm talking about angle A. Where is angle A? Here is angle A. So what is the opposite? Is it 15 or 8?
15.
Bravo. This is the opposite. And where is the adjacent?
8.
8. And where is the hypotenuse?
17.
17.
17.
So we know now where's the hypotenuse, and we mentioned when there's a hypotenuse, where is the opposite, and where is the adjacent. Now let's write the ratio.
Question.
Now, sine A. You have to write it like this. OPP, it's mean opposite over hypotenuse. Cosine A, you write it as ADJ. This is the mean of adjacent over hypotenuse. And tan A is the opposite. To write tan A, take the numerator here over the numerator of the cosine. Opposite over adjacent. Let's now solve them. Yeah. Where is the opposite to angle A? It is 15.
15.
Where is the hypotenuse?
17.
17. So cosine A is 15 over 17. Now cosine A.
8 over 17.
Yes,
8 over
8
17.
over 17. Bravo. And where is the tangent here?
15 over 8. 15 and 8. 15 and 8.
Bravo. Now, be careful. The sine and the cosine, it must sine, cosine, and tan. It must be positive values. This is the first thing. The second thing you must know that sine, it must be, sorry. Sine, as you see here, sine, it must be less than 1. Positive, yeah, between 0 and 1, less than 1. And the cosine, it must be less than 1. Tan, it could be greater than 1. It can be like this example here. 15 over 8, it's greater than 1. It can be. Okay? On sine and cosine, if your answer is like 12 over 6 as an example, this is incorrect. It must be less than 1 for the sine and the cosine. Tan, it could be greater or less than 1. It can be also less than 1. And there's no problem with tan. But for sine and cosine, it must be both of them less than 1. Let's have now another example. Here we have this triangle. I want to find sine, cosine, and tan of angle E.
Teacher?
Yes.
Can they be 1 or just less than 1?
Yes, it can be 1.
Okay.
Here, if you want to know that sine angle of 90, sine 90 is 1. Okay. Tan is 45 is 1. Today I will tell you now how else you can find any cosine and sine and tan of any angle by calculator. Now let's solve this one here. And it can be 1 and it can be 0, by the way. What does it mean? That means like sine 90 is 1 and cosine 90 is 0 and sine 180 is 0 and cosine 180 I think -1 or not is -1, like tan angle 45 is 1. What also? And so on. And that's mean the angle, it could be 0. Sorry, here. I'm sorry. It's not, cannot be, it must be, it cannot be positive only. It can be only negative. I'm sorry, I say it by mistake. But here, the most important thing that the sign, it must be less than 1, or inaccurate, it must be between -1 and 1. The cosine between -1 and 1 also.
Teacher, so can they be negative numbers?
Yes, but only -1. The maximum is -1.
Okay.
Okay. This is not so important for you. Just I want you to know how to find sine, cosine, and tan.
Miss, I didn't understand this point. Like, how we will know it's less than 1 or greater than 1?
No, this is an extra information, Huda. Don't confuse now. Okay, just focus now how to find sine, cosine, and tan.
Okay.
But here, just I want you to know that if you find like the sine is 5, this is wrong.
Okay.
This is a hint that you find it is greater than 1, this is wrong. That's what I want you to know. Now here, let's now come back to our lesson. Sine, now where is angle E? This is an angle E. Now where's the opposite?
G. Angle G.
Which is 9, I mean here. Where is the adjacent?
15. 15?
Adjacent.
12.
12. The longest side is the hypotenuse.
Oh, yeah.
Okay. Now, yeah. Now let's find the sine, cosine, and tan. Sine E, opposite over hypotenuse. Cosine E is the adjacent over the hypotenuse. And tan E is the opposite over the adjacent. Now, yeah, sine E for angle E here now. Where is the opposite?
9/15.
9 and the
9 over
hypotenuse 15. Bravo. Where is for angle E? Where is the adjacent?
12/15.
12
12
over
over 15.
12 over 15. And for tan E, where is the opposite?
9/12.
9 over 12.
12. Bravo.
Over 12.
That's it. Did you get the idea?
Yes.
Okay. Now,
Teacher, not very much.
yeah, because it's a new, it's a new idea. Now, when we solve an extra examples, inshallah, you will understand more and more.
So teacher,
teacher?
what's the difference of when they say sin F and cos L and tan F? How? And
How
they
what?
mean for the here teacher number 8 is sin F.
Sine F.
Sine.
Okay.
So they mean the sine is any angle F.
Yeah, this is the mean of that means sine of angle F.
Teacher,
Yes.
can you turn for the before this page 1 minute just?
Okay.
Okay.
Here, if I say sine E, that
Right,
means
teacher.
I have to look at angle E and to mention where is the opposite, where is the hypotenuse, and say sine is opposite over hypotenuse, and we write it like this, and we solve it.
So I have a question.
Yes, Hula.
Here in G, there is the angle.
Okay. This is the
So
right
what-
hand.
Yeah, the right angle, I mean.
Yeah.
So why from E we will start, not from G?
Start from why I'm starting from E, يعني?
Yeah, why you are taking the opposite and the hyphen and the
Adjacent.
adjacent.
Because okay, thank you. Because here I told you to find sine E. Sine angle E.
Oh, the question.
Yes, from the question, they told me find sine E. So I will say, okay, where's E? This is E. So this is the opposite. This is the adjacent.
Okay, miss, thank
But
you.
if I told you now sine F, you have to change everything. You have to change the opposite and you have to change the adjacent.
Okay,
Okay.
got it.
Now,
I finished the check.
you are welcome. Now, sum of the box. Since sine is opposite over hypotenuse, cosine is an adjacent over hypotenuse, tan is opposite over adjacent, they write them as an abbreviation. So, co, ta, to, like this. That means sine, this is S for sine. Sine is opposite over hypotenuse. Write it as, say it as so. Ka, that's mean cosine is adjacent over hypotenuse. And to, that's mean tan is opposite over adjacent. This is a way to memorize them. سكتوا. Okay, if you don't like to solve it or to memorize it, like according to me, I like to memorize it like this. Some of you may be like سكتوا.
Yeah.
As you want. It seemed to be like Chinese word. سكتوا. Okay. Now let's see here. This is problem 1. Okay, now before solving this one here, I will give you now, I will stop here, okay? I will give you now 5 minutes as a break. Then we will continue the next lesson.
Thank you, teacher.
Thank you, Miss.
Yeah.
Thank you so much.
Bye bye.
Have a nice day.
Okay, thank you,
Miss,
teacher.
when region?
After 5 minutes.
Okay, Miss.